Here we have the factored form of our polynomial from the previous video, and we will now change the irreducible quadratic factor into two linear factors. To do so, we'll start from the quadratic formula. Quadratic formula says negative b plus or minus root b squared minus 4ac divided by 2a will give us our values of x. We'll need to get a, b, and c from the irreducible quadratic piece. We can see that our a is the invisible 1, our b is negative 6, and c is negative 3. We now place those into the quadratic formula. We'll start from negative b, so we'll have negative of negative 6, which is positive 6, plus or minus b squared, but negative 6 squared is 36. We'll take that minus 4 times a, which is 1, times c, which is negative 3. We'll divide all of that times 2a, but 2 times 1 is 2. Now, we'll simplify what's in the root, starting with this piece that I'm boxing in orange, negative 4 times 1 times negative 3. If we multiply all of those together, we will get positive 12. So inside of the root, we now have root of 36 plus 12. We'll still have 6 plus or minus that, and 2 on the bottom. If we combine the 36 and positive 12, we will get root of 48. Now we'll try to simplify that root of 48. If we try to split up root 48 by dividing by a perfect square, we could take 48 divided by 16. 16 is a perfect square, and 48 divided by 16 will give us 3. This will allow us to split the root 48 into root 16, root 3. However, root of 16 is just 4, so we can rewrite root 48 as 4 root 3. We will now make that replacement. And rather than having 6 plus or minus root 48, we now have 6 plus or minus 4 root 3, and each piece will be divided by 2. Once we perform these divisions, 6 over 2 gives us 3, and 4 root 3 over 2 will allow us to simplify the numbers outside the root into 2 on top and 1 on the bottom, giving us 2 root 3. Therefore, our x values will be 3 plus 2 root 3, and also x equals 3 minus 2 root 3. Notice that these terms are not complex terms because neither are imaginary. However, because they do have roots, these are irrational solutions. We could not have found these irrational solutions with the methods that we used previously because our methods could only find rational roots. To find irrational roots, you still need to use the quadratic formula. With these irrational roots in mind, let us now simplify our irreducible quadratic. To simplify our irreducible quadratic, we will take all of the terms on the right side of these equal signs in our solutions, move them to the left, and change all the signs. Our first solution will give us x minus 3 minus 2 root 3. This will be our first linear factor that's irrational, and then we'll do the same to our other solution and end up with x minus 3 now plus 2 root 3. And so the only difference between the irrational solutions is the last sign. One is negative, one's positive. Therefore, we will split our x squared minus 6x minus 3 into these two factors. Our final factored form will go as follows. We'll still have 2 on the left, and our rationals, x plus 1/2 and x minus 1 that we found previously, now multiplied times our irrational factors, x minus 3 minus 2 root 3, and x minus 3 plus 2 root 3. This will be the completely linear factored form of this polynomial. So now, not only have we found all of the roots of our polynomial, we have also split it into completely linear factors. Thank you for watching. We'll see you again soon.